So in this second video looking at vectors, we'll be introducing the concept of resultant vectors, which is replacing column vectors with letters and working with more diagram exam style questions. Now before we get started, it's worth noting that in the description there will be a copy of all the notes you can see on the screen, so I recommend that you print them off or copy them off, and then obviously feel free to add any additional comments as you wish that they make sense as we're going through the video. And I'll also put a worksheet for you to practice some of the questions that are given in the examples below. So as well as using column vectors to represent a change in direction and distance, also known as magnitude, we can also represent vectors using letters or a combination of letters that represent a column vector. So for example, here we've got a set of letters on a grid that's slightly wonky. Now obviously here we've got no numbers of how long these boxes are, so you can imagine that they're squares. Well, that's the impression you can get, or rhombuses as you may want to call it, but we've got no indication about how big each of those rhombuses are. Now obviously if we just count in terms of squares, then we could say that P has got a column vector of 1, 0 because the vector is moving. And if I just get the pen, as you can see, it's moving 1 square to the right, and it's got no up down movement, so it's just 1, 0. And Q could be represented as 0, 1 because it's not moving left or right, it's just moving straight up like so. So we could give these numerical column vectors, but ultimately we don't know what they are because we don't know what the grid is. So we can't really use column vectors for this accurately, so we've got to kind of use a different method. Now this different method is, rather than using column vectors, instead, rather than giving numbers in terms of numbers in a column vector, instead we're going to give answers in terms of P and Q in this particular case. So, and this is, you tend to find this on more high level questions, so often where letters are used, the column vectors are not given and so are irrelevant. So almost always a diagram is given when letters are used along a lined arrow that represent both the direction and distance of the vector. Now when this is given, you can only follow these movements. However, to go in the opposite direction of the vector or the arrowed line, you must change the sign of the vector and all its components. So in other words, if we look at these 4 examples you can see on your screen, and I'm just going to number them 1, 2, 3 and 4. Now typically when you have got a high level vectors question, you won't be given column vectors. Instead you'll be given these sort of notations of letters that represent a column vector, but we don't know what those column vectors are, we just know what they're called. So for example in 1, now we can imagine like these are the movements that we could potentially do. Now if I'm going to go up, which is in the direction of this arrow here, and again I'm assuming it's up because of the arrows pointing in that direction, then that is what we call positive A, which is basically whatever this is. So therefore to go down along that line in the same direction, well in the opposite direction, that's going to be minus A, so it's the opposite sign. So whatever the sign is, I need to change it. So here on the diagram, to go right, that's going to be B. So to go in the opposite direction, which is going to be left, that's going to be minus B. So with diagram 1, this is the sort of cursors. So if you imagine like a really basic computer game, you can only go up, down, left, right, then these are the directions I can go. So if you're going to go against the arrow line, you need to change everything positive into negative and everything negative, that's positive. Now if we look at example 2, and again I'm going to use a different colour for this. So to go up, and again the reason why I know it's up is because the arrow is going up, that's positive 3A. So to go down, that's going to be just change the sign, so that's going to be minus 3A. Now to go to the left, which is what this arrow here is doing, that's A plus B. So to go right, which is the opposite direction of the arrowed line, I change everything positive into a negative and everything negative into a positive. So to go right, it's going to be minus A minus B, like so. Now if you move on to question 3, and again I'm going to go up, down, left, right, because I'm just going in the opposite directions. So looking at this diagram, to go up, that's positive 3B. And to go down, then it's going to be the opposite, so I just change the sign, so it's minus 3B. Now in this, to go left, it's, and again to change the colour, let's stick with blue. So to go left, it's 4a minus b. So to go in the opposite direction, well, the 4a is positive, so now it's going to be negative. And the b is negative, so now it's going to be positive. So all I've done is I've just swapped the signs over to go in the opposite direction. And then finally for question 4, again I'm going to go up, down, left, right. So to go down, which is what this line here represents, I need to go minus 2a minus b. So to go in the opposite direction, it's going to be plus 2a, because 2a was negative, and then rather than having minus b, I'm now going to have plus b. And likewise to go right, it's 6a. So to go left, I change the sign, so it's going to be minus 6a. And there you can, lo and behold, you've now got your directions to go up, down, left, right in any of your diagrams. So the key thing to note in this is that when you're going with the arrow, you just copy whatever the vector is and whatever letters are being used. But if you're going in the opposite direction, against the arrow, then you need to change whatever's positive into a negative and anything that's negative into a positive. So let's have a look at some common examples. So this question here is very, very common when it comes to introducing the concept of letters representing vectors. Now in this particular question here we've got the alphabet, and that's extended, so it goes beyond. So here we've got A dash, B dash, C dash and D dash, and what we're asked to do is write down the vectors to get from one letter to another. So in terms of this, when we've got A to N with an arrow, it means that you're starting at the first letter and you're ending at the second letter. So here we're starting at A and you're ending at N. So if I had something that said B to K, then here and going in the opposite direction, so this would be where you're starting at K and you end at B. So it's always important you understand the notation of what we're actually looking at. And again, so that's what the arrow with the two letters actually mean. The first letter at the start of the arrow is where you start at, and the letter where the arrow kind of appears, that's where you end at that letter. So for question A, now again, before we get started, let's have a look at the movements that we can make. So if I just draw like a little control system, so to go up, that's going to be Q. I'm just going to write up here, and to go down, that's going to be minus Q, and that's to go down, because again it's just the opposite directions as to what it is. Now to go right, that's P, and to go left, that's going to be minus P, and that's to go left. So, and what I'm going to do is I'm going to use this as a guide to help me work out what the column vectors, what the vectors are going to be. And again, where I've got all of this information from is from this diagram, and looking at where the arrows are facing, so I've got this kind of like a cursor control. Now looking at A to N, so the first thing we need to do is establish what letter we're starting at. Well, we're starting at A, so that's here, and I'm going to end up at N. Now going along the paths of A to N, now the nice thing about vectors, it doesn't matter whether you're going a long route or a short route, the answer will always be the same when you simplify it. Obviously if you then go on a crazy diversion, you've got more work to do, so the more direct route you can go, the better. Now I can only go left, right, up, down. I can't cross any of these squares because it goes against my actual controls that I can use. So I've got to use the grid lines to go from A to N. Now to go from A to N, what I need to do is I'm going to go this route here. So what I'm going to do to go from this route here, I'm going to go, so A to N, if I just I'm running out of space, A to N is up, up, and then right one square. So I'm going up, up, and then right. Now looking at my directions, what I'm going to do is rather than writing up, I'm going to write Q, and it's plus Q. Up again is plus Q, and right is plus P. So let me just stick a few pluses in there. Let's get rid of that. And like so. And then what we need to do here is collect the like terms. So here, Q plus P is 2Q plus P, and there is my final answer. So I can write this as 2Q plus P. Again, if you don't underline your answers, that's absolutely fine, don't worry about it, but that there would be your final answer. So if I just get rid of this and move on to the next question. So here we're going n to y. So I first find n and I'm going y here. So the route I'm going to choose to go, I'm going to go this route here. Like so. So to go from n to y, I'm going to go up, up, and then left, left. So up is q, or plus q. Up again is plus q. Left is minus p, and left again is minus p. So if I then collect the like terms, what have I got? Well, I've got q plus q is 2q, and minus 1 times minus 1 plus minus 1 is minus 2p. So the answer to question 2 then is 2q minus 2p, and there is my final answer. And then moving on to question 3, so this here we're going from k to d dash. So again, if I just get rid of all of this, so here let's use different colour, let's go for red. So here I'm starting at k, which is here, and I'm going to d dash, which is here. So starting at k, I'm going to follow this route here. So what I need to do is, so k to d dash is up, plus up, plus up. So up is q, plus q, up again is plus q, up again is plus q. So q plus q plus q equals 3q. So the final answer for this is 3q. Again, you can put an underline next to it because it's vectors. So again, looking at question 4, so here we're going from V to S. So again, just pick a different colour, let's go for purple. So here I'm going V to S, so first let's find V, which is here. Let's find S, which is here. So I'm going to go along this route here. So V to S is left, left, and then left. And again, left is minus p, so I've got minus p, minus p, minus p. So minus 1 plus minus 1 plus minus 1 is minus 3p. So the final answer there is minus 3p, and I forgot the minus, so let's just stick that in. And there is my final answer. Now the good thing is about this is if we just remember that the answer is minus 3p, let's say I'm going to go along some crazy route to get from V to S. So let's say I'm going to go up here, then I'm going to go along there, then I'm going to go down, and then I'm going to go to S. So I'm going to go up here and along there. So that's some crazy route. So first of all, from V to S, I'm going up, then left, then left, then down, and then left. Now if I convert that into my letters, well, up is q, plus q, left is minus p, left is minus p, down is minus q, and left is minus p. Now here, if I now collect my like terms, well, I've got q, take away q, well, that cancels out, and minus 1 plus minus 1 plus minus 1 is minus 3p. So you can see how I get the exact same answer as if I went direct route, and that's what kind of working with these vectors actually is. It doesn't matter whether you go the long route or the short route, the vectors in its simplified form will always give you the same answer. So it doesn't matter what route you go in. So if you decide to go a different route to what I'm doing on the screen, you should still get the same answer. So then moving on to question 5, so here we're going to JL. So let's get rid of all this. So J to L, I'm going to go, so let's first find J and let's find L. So again I'm going to go, let's go this route here. So here I'm going to go left 4 places, so left, plus left, plus left, plus left. I should have just used L, it would have been quicker, plus up. So then converting that into, let me just make that a little bit thicker. So here, converted that into the letters, well, left is minus p, minus p, minus p, minus p, plus q. And if I simplify all of that, I get minus 4p plus q, and there is my final answer. So it's minus 4p plus q. And there we go. And then finally for this section we've got g to z, or z for our American friends. And for this one we're going from g, so g is here, z is here, so again I'm just going up 3, so g to z is up, 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 and again I'm going q, 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 and if I join them together I get 3q, so the answer here is 3q, which is the same answer we get in 3, but it still gives us the correct answer. Now with this second question here, what we've got to do is the question says to write down any letters that is equal to 3p plus 3q. Now first things first, let's translate what 4p actually means. Well, 4p means we're going up 4 squares, right 4 squares. So right 4 squares, and 3q plus 3q means we're going up 3 squares. So what we need to do is find a letter that when we start at so if I just pick a random letter, so let's go for H, and we're going to go up right 4 squares, so 1, 2, 3, 4. Now I can't do H because there's not enough squares for me to go right, so let's pick G instead. So here I'm going to go 1, 2, 3, 4, and then from there I need to go up 3 squares, so 1, 2, 3, so I get to D dash. So one qualifying letter is G to D dash. Now there are several different combinations depending on where you start at. So if I was starting, let's say, now there are only certain ones where you can actually start at. So the ones you can start at are going to be at these 4 here, like so. And if you end up with those, we end up here and here, and for the red ones it was here and here. So if my starting one is red 1, I would end up at C dash. If I start at G, I end up at D dash. If I start at O, I'm going to end up at, if I just label that 1, that's going to be 1 dash. And if I start at A, which I just called 2, that's going to be 2 dash. So in terms of your possible answers that you could have correct for this particular question, you could have, so possible answers, and there are a few, is you can have either F to C dash, or you could have G to D dash, or you could have O to W, or you could have A to X. And they'll be the ones that would fit actually on your grid. So any of those two would be absolutely fine. Now the type of exam question you can see on the screen is pretty much one of the hardest questions you'd get at this particular level of looking at vectors. It does get a little bit more complicated, but that will then appear on the higher GCSE paper rather than the foundation paper. So with regards to this particular question, here we've got 4 points on a shape, and we've got A, B, C and D. Now we've been given the vectors of getting from A to B, B to C and C to D. So to get from A to B, then that's going to be 2A plus B. B to C is 3B, and C to D is going to be 4A minus 2B. Now if I just quickly change the arrow, and I will change it back. If the arrow was going in the opposite direction, what's going on here? We'll just write that there. So let's say we had the arrow going in this direction here, then D to C would be 4A minus 2B. So you've always got to go from the letter in the same direction as the arrow. So it is really important you do look at the direction of the arrow. Now from this, and let's just change this back to how it was. So from this, what we now need to look at is write down the column vectors to get from A to B. Now, before we go on to answering these questions, what I'm going to do is I'm just going to do a little diagram. It's going to mimic the exact same one as you can see on your screen. But what I'm going to do is I'm going to go in the opposite directions to what you can see. So here we've got A, B, C, and D. So here, if I was going to go from B to A, following that direction, then that's going to be minus 2A minus B. If I'm going from C to B, that's going to be minus 3B. And if I'm going from D to C, it's going to be minus 4A minus 2B. So if you're going in the opposite direction, you just need to change the signs of the letters. So now with these two diagrams, that can help me answer A to B. Now A to B, so I need to find A, find B, and I'm going the arrow that takes me in that direction. So for A, for question 1, sorry, it's going to be simply 2A plus B. And there we go. For question 2, well, here I'm going to go from A to B. So to get from A to C, I'm going to go the route of A to B plus B to C. So A to B is 2A plus B, and B to C is 3B. Now if I use my knowledge of collecting like terms, then this is going to give me a final answer of 2A plus 4B, and there is my final answer. And then to get from B to C, well, again, that's just going to be simple as just 3B. Now to get from C to B, I need to use the second diagram, so I'm going to go in the opposite direction of the arrow on the diagram, so I need to change the sign of the vectors, so that's going to be minus 3B. Now B to D, well, to get from B to D, I need to go from B to C and then B to D. Now B to C is 3B, and C to sorry, it should be C to B rather a D, sorry, and about half the answer question. So C to D is 4A minus 2B. So if I collect the like terms here, I've got 4A plus 1B. If you want to write 1, that's fine, or just B, that's also fine as well. So the correct answer you should have for question 5 is 4A plus B, or 1B. Let's just write that down. So 4A plus B. Now to get from D to B, so D to B, I'm going to go the route of D to C and then C to B. Now D to C is going in the opposite direction, so that's going to be minus 4A plus 2B. And then C to B is going in the opposite direction, so that's going to be minus 3B. And then working this out, I've got minus 4A, and then 2 take away 3 is minus B. That should be an A there. So the correct answer we should have for question 6 is going to be minus 4A plus B. And there's our answer there. Now to get from C to A, or C to A, is going from C to B plus B to A, and so C to B is minus 3B, and B to A is minus 2A minus B, and if I join that all together I get minus 2A minus 4B. So the answer I should have for question 7 is minus 2A minus 4B. Like so. And then finally for this question we've got D to C, which is going in the opposite direction, so this one relatively easy, so I'm going the opposite, so it's going to be minus 4A plus 2B, and there is my final answer there. Now for the extension question, again this is really going into higher. So for this, what it's saying is the question says that M is the midpoint of C to D. So if I just mark the midpoint, which is here, I'm going to call that M. Now with it being in the middle, now if all the distance going from D to C to D is 4A minus 2B, then the distance of C to M, with M being the midpoint, is going to be half of that. So that's going to be 2A minus 1B. And all I've done there is just divided these two numbers by 2, in which I get this. So the distance here is going to be 2a minus b, and if I join those two things together I'm going to get the total vector here. So the question's asking me to go from a to m. To get from a to m, the route I'm going to go is I'm going to go a to b plus b to c and then c to m. Now a to b is 2a plus b, b to c is 3b, and c to m is going to be 2a minus b. And again, if I use my like terms to work this out, so I've got 2a plus 2a is 4a, and I've got 3b, take away 1b gives me a positive 2b, and there is my final answer. So as you can see, it does get a little bit more difficult, it does get a little bit more complicated, but the easiest thing for you to do is to break the paths into small sections. So if you're asked to go from A to C, then work out a plan. Right, okay, you can only go along from one letter to the next letter along the path that's shown on the diagram. So to A to C would be equal to A to B plus B to C. And the other key thing to remember, and to summarise in this video, is if you're going in the opposite direction to the arrow, you change whatever's positive into a negative and everything's negative into a positive. So you just change the sign of everything in the vector, and always make a note of what direction the arrows are going for you to then make a concerned effort as to whether you just need to use that value or do you need to change the signs. And obviously good knowledge of collecting like terms is definitely going to be handy, particularly when you're answering these types of questions.